This animation provides a schematic view of the production process and chemical structure of VACA silicone resins. Monomeric silanols are an example of a raw material used for silicone resins. These react with each other to liberate water. The reaction is stopped when a desired degree of polymerization is reached. The product of the reaction is a roughly spherical polysiloxane. This is the silicone resin. Depending on the degree of polymerization, the resin will be either a liquid or a solid. The surfaces of the resin molecules still bear reactive groups that allow them to cross-link with each other. Reactivity is low enough, however, to ensure adequate storage stability. Cross-linking at the surface doesn't continue until the silicone resin undergoes significant heating and, in some cases, has been mixed with suitable catalysts. This, in turn, releases byproducts from the resin. Depending on the type of resin, these can be water or an alcohol, such as methanol or ethanol. Once complete, curing produces a very dense network, which is why the cured resin is relatively hard and brittle. SILRES MK is a solid silicone resin, shown here in the form of flakes. It is also available as a powder. The silicone resin begins to melt at a temperature of 40 degrees Celsius, and melting takes place faster at higher temperatures. The melting process is essentially reversible, as significant cross-linking takes a relatively long time. Suitable catalysts are required for the molten silicone resin to cure quickly. GENIOSIL GF 91 is shown here. A catalyst concentration of only a few weight % is enough to trigger cross-linking. The cross-linking process releases water and alcohol. The viscosity also increases rapidly, allowing air to be stirred into the silicone. Taken together, these cause the material to foam slightly. Within only 1 minute of adding the catalyst, cross-linking has progressed to the point where the material begins to solidify. Molten uncatalyzed SILRES MK, by contrast, can be heated to elevated temperatures for relatively long periods of time with no significant rise in viscosity. SILRES H62 C is a liquid, solvent-free silicone resin that already contains a sufficient amount of a platinum catalyst. SILRES H62 C cures from a temperature of roughly 160 degrees Celsius, although temperatures of 200 degrees or higher are preferred. Unlike standard silicone resins, this does not release any byproduct, making it particularly suitable for compact encapsulation or for electric motor impregnation. The hardness of the finished cured rubber is roughly 60 Shor-D. Nevertheless, SILRES H62 still offers a flexural strength of 30 megapascal. Please see our product brochure for more precise information on processing and material properties.